Hello all, good morning. Welcome to Unacademy. Today we will going to discuss our next chapter from the discrete mathematics. Okay. So in this lecture, we will see how to solve the examples on logic, mathematical logic. It's a very simple part, but still it's a part of your syllabus, so we will complete it. Okay, before going to start this, I will introduce myself. Myself, Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience. Now, here I will tell you how to install the Unacademy's Learning app. First, go to your mobile's Play Store app, then search Unacademy's Learning app. After that, install the app and here go to your you have to manage your goal here. So जैसे कि हम लोग यहाँ पे अभी गेट एंड ईएसई के लिए पढ़ रहे हैं, इंजीनियरिंग फाउंडेशन यहाँ पे हम लोग कर रहे हैं. So you will manage your goal here, GATE and ESE, and then you can take any subscription plan, either plus subscription, free courses, special classes. It is up to you. You can choose any one of that and press the button get subscription so that you will get the subscription of Unacademy's Learning app. And after that, if you are going to prepare for the uh, exam GATE 2022, then I will suggest you go for the 24 months plan here. Now for the plans, 12 either you can select for 12 months plan, 24 months plans, it is up to you. And you can use to get the 10% discount on your subscription fees, you can use my promo code DSP, and then we'll proceed for the payment. You can pay your subscription fees by using any one of this app. Okay. And to unlock the free subscription plan of Unacademy with special class like test series, quiz and Unacademy combat, you can use my promo code DSP. Now we'll start our actual topic, that is mathematical logic. Okay. In this we will see the definition, statement, what do you mean, what is the definition of a statement and the truth value of a statement, logical connectives, disjunction, conjunction, then conditional connectives, if then, biconditional connectives, everything we will cover in this lecture. Okay. Now, first of all, we will see the definition. What do you mean by statement? Okay. What do you mean by statement here? You can see the statement. Now, statement is a declarative sentence with the definite truth value. Okay. Statement is a declarative sentence. It is a declarative sentence with definite truth value. With definite truth value. Okay. So we will see some example. What are the statement? Now suppose if you write take the statement sentence. Suppose Pune is a capital of India. We see Pune is a capital of India. We'll say, is this true? Capital of India. Is this statement? Pune is a capital of India. Is this statement? Yes, it is a statement. Declaration. It is a declaration. It is a declarative sentence with definite truth value. So, Pune is a capital of India. Yes, it is a sentence or it is a statement with the truth value false. Right? With the truth value false. It is a statement with the truth value false. Now, next suppose here we'll take, suppose y plus 8 is equal to 12. Is this a statement? Is this a statement? No, this is not a statement because here value of the truth value of this sentence is depending upon the values of y. Sometimes it will true, sometimes it will false. So it is not a statement. Here a declarative statement, it means what? A declarative sentence with a definite truth value. Either the truth value is false or the Either you will get the truth value false or it is uh, true. Okay, both will not be possible. Okay, this is your declarative sentence. Okay, now we will see different examples of this. A sentence with a okay, now here this is not a statement. Why? This is not a statement. Why it is not a statement? Because here the values of this truth value of this sentence is depending upon the values of y. Right? Truth value of this sentence depending upon the values of y. For some values of y, the statement will be true. For some values of y, the statement will be false. Therefore, it is not a statement. Clear? Now, next we will see here truth value of a statement. The statement has a definite truth value which is either true or false. Okay? Statement has definite truth value either false or true, right? Either false or true, as we have seen here. So to treble, so we will see the logical. Now statement has definite truth value either false or true, and false value is denoted by F, truth value T is denoted by, true value is denoted by T. Okay, now we will see the logical connectives. Okay, what are the logical connectives? What do you mean by connectives? Okay. Now every statement must be either true or false, but not both. Okay, so every statement must be either true or false, but not both. That we will see here how it is logical connectivities work. So suppose if the two statements are joined by and, then we will use the logical connective conjunction. Okay, first logical connectives is conjunction, right? Conjunction, it means what? If a P and Q are statements and the compound statement is the compound statement joined by and. Okay, if P and Q be the statements, the compound statement joined by and, it's called a P conjunction of Q, right? The statement is called as P conjunction of Q. Suppose there are two statements, P and Q, and if these two statements combined by and, then that is your conjunction P conjunction Q. That statement we can say that P conjunction Q, or it is denoted by and. Conjunction is denoted by and. Okay, so come P and Q, it means either P, both P and Q. Okay, now and denotes known as the conjunction. This is known as a conjunction. Okay, now next we will see here the statement truth values of the conjunction. If two statements are given, then what are the truth values of the given conjunction statement? We will see first sentences. For example, suppose P is a statement, Chalaka is in senior KG. Okay, Chalaka is in senior KG. And Q be the statement, Shalaka likes drawing. Shalaka likes drawing. Then P and Q is a statement. Then P and Q is a statement. Then P and Q is a statement. How it is statement? Here P and Q is a statement. Shalaka is in senior KG and she likes drawing. Right? She likes drawing. This is your conjunction. Okay? And Shalaka is in senior KG and she likes drawing. Right? So we will see here truth table of P and Q. Suppose this is your statement P and Q. The next table P and Q. Statement P, Q and the truth values of P and Q. Okay. So how we write the truth table for this and conjunction? True, true, false, false. Right? Here is true, false, true, false. Now we'll write the conjunction of this table by different color. So here P both are true, then also it is true. Okay. If one of them is false, then it is false. If one of them is false, then it is false. If both are false, then also false. This is the truth table of P and Q. You getting it? P and Q. Truth table of P and Q. Right? So here P and Q is denoted by this. Now we will see the next uh, conjunction connectives is disjunction. Okay? Second connectives is disjunction. What do you mean by disjunction? If two or more statements are combined by the word or. If two or more statements, if two or more statements combined by the word or, the compound statement is called disjunction, right? The compound statement is called disjunction. The compound statement is called disjunction and it is denoted by or. Okay, it is denoted by this letter or, this symbol or. So P or Q, it means this is a compound statement of disjunction. P or Q, P disjunction Q. Also read as P disjunction Q. Now we'll see the truth table for this or P, Q. Here true, true, false, false. Here P or Q. Here P, F, P, F. Denoted by this P or Q. If both are of true, then also it is true. Okay? If one of them is true, then also true. Only if it is false when both are false, right? Only it is false when both are false. So there P or Q is equal to here P or Q bind statement here. P or Q is T, 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 F. Okay. For example, we will see any example here. Suppose P is a statement. We will see. P is a statement. Here, I will purchase a dress. Right? I will purchase a dress. Right? I will purchase a dress. Q will is a statement. I will purchase a book. I will purchase a. So what is your P or Q is a statement. P or Q is a statement. I will purchase a book, dress. I will purchase a dress or a book. Right? I will purchase a dress or a book. Right? This is your I will purchase a dress, or I will purchase a book. This is your disjunction of P or Q. Disjunction P or Q. P disjunction Q. Okay. Now we move for the next logical connectives. That is, here we will see the next logical connectives is negation. Negation, it means third logical connectives. Negation, it is denoted by this negation. Okay. Now, if I shall go for a walk, or I will watch a TV, right? So here we will see, no, we'll take one more example. Negation, whenever it is true statement, negation of true statement is a false. Negation of a false statement is a true statement, right? So negation of the statement P and Q are, so suppose this is your statement P, right? And here Q, T, T, F, F, E, F, P, F, right? So negation of P will give you false, false, true, true. Negation of Q will give you false, true, false, true. Opposite. If it is false, then the negation is true. If it is true, then negation is false. Okay. Now, for example, if P is a statement, Ram is intelligent, right? Ram is intelligent. Intelligent boy. Okay. So what is the negation of P? Negation of P is Ram is not intelligent boy. Ram is not intelligent boy. This is negation of P statement. Okay. Now we'll see the next logical connectives is fourth one, conditional statement. Okay. Conditional statement. Which is conditional statement? If then. If this is, then this. If then. So we will see. P is a, I will tell you one example. Suppose P is a statement. Akash gets 90%. Akash gets 90% and or more in 12th examination. In 12th exam. Okay. Q is the statement. Akash will get admission. Akash will get admission for engineering course, right? For engineering course. Now, what is the statement? Conditional. How we can write P implies Q here? P implies Q is a statement. If Akash will get, if Akash will get 90% or more marks in 12th exam, then he will get a admission for engineering. Then he will get admission for engineering. So this is your compound statement of the two given statement, right? If Akash will get 90% or more marks, then in 12th exam, then he will get admission for the engineering course, right? This is your compound statement if then. Okay. Now we will see the truth table for the compound statement if then. Suppose this is your P, Q, then and it is denoted compound statement, conditional statement is denoted by this arrow. P implies Q. We also read as it is P implies Q. So T, T, F, F, T, F, T, F. So P implies Q. How will write the truth table? It is false only when first is true and second is false. Right? The statement is false only when the first is true and second is false. Otherwise, it is true. So true, true, true. Right? The statement is logical connectivities is either one of them is false. It means only second case is false. Then only it is false. Otherwise, it is true. This is a truth table for the logical connectives. If then. Now we'll see the next logical connectives. Biconditional, biconditional, or it is if and only if statement, right? Or double implication, we'll also say that. So P and Q is conditional statement, then we can denote it by here biconditional statement. P double implies Q. If this, then this. If this, then this. Right? So this arrow, it means P implies Q and Q implies P. Both are true here. P implies Q and P implies Q and Q implies P is called the biconditional statement. Right? Now this is your biconditional statement. Now we will see the truth table for this biconditional statement. So we'll write the truth table for this biconditional statement. P, Q, okay. P implies Q. Okay. So here T, T, F, F, P, F, T, F. Right? In a biconditional statement, both are true, then it is true. And if both are false, then also it is true. Otherwise, it is false. So very simple. Both are true, then it is true. Both are false, then also it is true. And if one of them is false, then it is false. Okay. So this is your biconditional. The next connectivity is exclusive OR. Exclusive OR. It means either or. Okay, either this or this. Then how this? I will write. Okay. Now suppose, and it is denoted by either or is denoted by P ring sum Q. It is called as P ring sum Q. Either or is denoted by P ring sum Q. Now how we can write P ring sum Q here? P ring sum Q, it means either P or Q. Here is either P or Q. We can say here either P or Q. Okay. Let's see P or Q. How we can write here P or Q. Either or Q. The truth table for exclusive OR is P, Q, P or Q. T, T, F, F, T, F, T, F. Right? How it is denoted P or Q. Here P, T, T, then false. F, F, then also false. Otherwise it is true. Remember this. If both are true, then it is false. If both are false, then it is also false. Only when one of them is true, then it is true. One of them is false, then it is true. Okay. So this is your either or statement. Now, we will see, for example, P is a statement. I shall go for a walk. I shall go for a walk and I shall go for walk. Q, I will or I shall watch TV. I shall watch TV. So what is your statement? P ring some Q. Either or is the statement. Either I shall go for a walk. Either I shall go for a walk or I will watch a TV. Okay? I shall watch a TV. So either or it means what? Exclusive or it means what? Both the events we cannot do simultaneously. Either you will do first event or you will do second event. Both event cannot do simultaneously. That is your exclusive or statement. Okay. Now, forward we will see now all the tables we know. Now we will see the examples how to write down the all the statements and okay, contrapositive and implication. You see, your contrapositive or implication. We'll write first upon the table so that in a one table you will get all the truth values. Right? Here P, Q, we will revise once again. Here P and Q. So negation of P we can write here. Then P or Q, conjunction, P and Q. So here disjunction, this conjunction and Q. P implies Q if then P double implies Q if and only if P rings some Q, right? We will see truth table for this. T, T, F, F. Write the table. In one table, you will get all the truth values. T, F, T, F. The negation of P, it means here, right? Negation of P is F, F, T, T. Okay, write in a different color. P or Q, it means if both are true, then also true. One of them is true, then it is true, otherwise it is false, right? Next, we will see here P and Q. If both of them is true, then only it is true, otherwise it is false, right? Now, P implies Q. If second is false, then only it is false, otherwise it is true. Yeah. P double implies Q. If both are true, then it is true. Otherwise, both are false, then also it is true. Otherwise, it is false. Right? Now, next is P rings some Q. P ring sum Q, it means if it is if both are true, then false, both are false, then also false. If one of them is true, then it is true. Now this is your combined table of truth table of the given. Now this is your combined truth table, right? Combined truth table for the given statements. Either it is true, false for the or statement, for the all the connectivities. Here we can see negation, here disjunction, conjunction, conditional, biconditional, exclusive, or. Okay, all the values of the truth table are given here. We will see how to solve the examples depending on this. Now, express the following statements. Here, express the following statements in the propositional form. Here, express the following statements in a propositional form. There are many clouds in the sky, but it did not rain. Okay, we will write down it is one by one. There are many clouds in the sky, but it did not rain. So how we'll write? First of all, we have to write down the statement P and Q first. Okay, so first one, P is the statement. There are many clouds in the sky. There are many clouds in the sky. Q is the statement. It rained. Right? There are many clouds in the sky. Q is the statement. It rained. So we can write that statement. There are many clouds in the sky, but it did not rain. So we can write in a propositional form. There are many clouds in the sky and it did not rain. So negation of Q. This is your propositional form of the given statement, right? P and negation of Q. So this is P and negation of Q is the propositional statement with the given statement that there are many clouds in the sky, but it did not rain. Okay. Now second statement is given that I will get first class if and only if I study well and score above 80 in mathematics. See, so for that, I have to write the statements. There are how many statements? Combined statements. See, I will get first class. This is first statement. And if and only if I study well, this is second statement. And score above 80 in mathematics, this is third statement. So you have to write here three statements. So write down here P. P is the statement I will get a first class. Okay. I will get first class. Q is the statement I study well. R is the statement score above 80 in mathematics. Score above 80 in mathematics. Right? So I will get a first class. I study well. R is the statement score above 80 in mathematics. So we can write this statement in a propositional form if and only if statement is given, right? I will get a first class if and only if. So it means definitely there is a biconditional statement. So I will get a first class if and only if I study well and score above 80 in mathematics. So I will write this statement here. P if and only if I will get a first class if and only if I study well and score above 80 in mathematics. So and R. So this is your propositional form. I will get a first class. I study well, score about 80 in mathematics. So this after reading this we will get immediately I will get a first class if and only if I study well and score above 80 in a mathematics. Okay. Now, third statement you can see here, computers are cheap but softwares are costly. Now we can write this. So first of all, you write down you have to recognize which logical connectivity here used. Computers are cheap but softwares are costly. So instead of but here, we can use, which logical connectives we can use here? Computers are cheap but softwares are costly. So but it means here and, right? We can write here and statement. But you can write here third one. P is a statement. Computers are cheap. Computers are cheap, right? Q is a statement. Softwares are costly. Softwares are costly, right? Computers are cheap but softwares are costly. Now this is your statement. So we can write by using the logical connectives here. So P, computers are cheap but softwares are costly. It means and. So P and Q is the your total connectivities by using logical connectivities and here. Computers are cheap and softwares are costly. Okay. Now we'll see the third one statement. Fourth one. It is very hot and humid or Ramesh is having ear problem. It is very hot or humid and here not here is heart problem. There's a printing mistake. Here is heart problem, right? So it is very hot and humid or Ramesh is having heart problem. So how many statements are there? It is very hot is one statement, right? It is very hot is a one statement and humid it is again a statement, or Ramesh is having heart problem. So how many statements are combined here? 1, 2, 3. So first of all we will write the separately the statement P. P here, P is, it is very hot. It is very hot. Q is the statement. It is very humid. It is very humid. R is the statement. Ramesh is having heart problem. Right? Ramesh is having heart problem. So we can write in a combined way. So it is very hot and humid or Ramesh is having heart problem. Very simple way we can write down here. It is very hot and it is Ramesh is having heart problem, right? Now, fourth one. In a small restaurant, the food is good and service is poor. So I will write, now it is very simple. Fifth one, we can write in a small restaurant. P is the statement. In a small restaurant, right? In a small restaurant, food is good. Food is good. And what will be your statement Q? Service is poor. Service is poor. Okay. So we can write here propositional form. In a small restaurants, food is good and service is poor. And logical connective. Fifth one. We can see here sixth one. If I finish my submission before 5 in the evening and it is not very hot, I will go and play a game of hockey. So there are three statements. So we can write here three or four statements. If I finish my submission, this is one statement. Before 5 p.m. in the evening, this is one statement. And it is not very hot, second statement. I will go and play a game of hockey. I will go. This is third statement. And play a game of hockey. It will fourth statement. Okay, so there are four statements here combined. So we can write here P. P is a statement. I finish my submission. I finish my submission before 5 p.m. Before 5 p.m. Q is the statement. It is very hot. R is the statement. I will go. And S is a statement. I will play a game of hockey. Play a game of hockey. Right? So we can write it. We can write these statements. I finish my submission. See the statement. I finished my submission before 5 in the evening and it is not very hot. So it means negation of, here you will get Q. So P and negation of Q if, then I will go and play a game of hockey. So R and S. This is your propositional form of the given statements. Okay. Now we will see here the next question. Let P denote, exactly similar way we will use. Let P denotes the statement, the material is interesting. Here, the material is interesting. And Q denote the statement, the exercises are challenging. And R denote the statement, the course is enjoyable. Write the statements in a symbolic form. Okay. Now, here we will see how we can write the statements in a symbolic form. Let P denote the statement and the material is interesting. So, symbolic form, the material is interesting and exercises are challenging. And statement. So, how we can write this? First one, P and Q. Very simple. P denotes the material is interesting and exercises are challenging. P and Q. Okay. The material is interesting or the exercises are not challenging and conversely. Okay. The material is interesting and the exercises are not challenging and conversely. How we can write P material is interesting, so P, or the exercises are not challenging. So P implies Q. The material is interesting or the exercises are not challenging and conversely. So conversely it means P double implies Q, right? So either you can write P implies Q and Q implies P. Material is interesting or exercises are not challenging. Not challenging, it means here negation of Q. P implies negation of Q and Q implies P. Okay. So this is your third statement. Either the material is interesting or the exercises are not challenging, but not both. As I told you, but not both. It means what? Here, it's either the material is interesting or the exercises are not challenging, but not both. It means here you can write either or, exclusive or, right? So we will write here P brings some negation of Q. Either the material is interesting or the exercises are not challenging. There is not vice versa. Okay. P either exclusive or P brings some negation of Q. Now fourth one, if the material is not interesting and the exercises are not challenging, then the course is not enjoyable, right? If the material is not interesting and the exercises are not challenging, then the course is not enjoyable. So if then, so P, if the material is not interesting, here negation of P. And exercises are not challenging, negation of Q. If this, then the course is not enjoyable, so negation of R. Yeah. Negation of P and negation of Q implies negation of R, where here P is the statement, Q is the statement, and R is the statement already given. Now, the material is uninteresting, it means not interesting. Material is uninteresting and material is uninteresting, the exercises are not challenging, and the course is not enjoyable. Here, not it is not given, it means and. The material is uninteresting, so negation of P and negation of Q and negation of R. Negation of P and negation of Q and negation of R. The material is not interesting and the exercises are not challenging and the course is not enjoyable. Okay. Now this is your, the statement is given in a word format. You have to convert it in a symbolic form. Okay. Now next we will see, suppose here, okay, express the contrapositive, inverse, converse and negation forms of the conditional statement given below. Okay, conditional statement given below, suppose P conditional Q, P implies Q is a statement, then how we write down the contrapositive, converse and inverse. Okay, so contrapositive you can write it here, P implies Q, contrapositive is negation of Q implies negation of P, right? First one. Then converse. What is converse here? Converse is P implies Q. Converse of this statement is Q implies P. Third, inverse is negation of P implies negation of Q. Negation of P implies negation of Q, right? Contrapositive, converse and inverse. So we can write this statement, if X is a rational, then X is a real. So P is a statement, X is rational. Q is a statement, X is real. So what is our first statement? If X is a rational, so contrapositive we can write here first. Contrapositive. So P implies Q. Contrapositive of this is negation of Q implies negation of P. Negation of Q implies negation of P. Right? So we can write the statement, if X is not real, if X is not real, then X is not rational. If X is not real, then X is not rational. This is first. Second one, converse. Q implies P. So we can write Q implies P here. If X is real, then X is rational. Right? Then we can write inverse, third. Negation of P implies negation of Q. So it means if X is not rational, then X is not real. If X is not rational, then X is not real. This is your converse, contrapositive and inverse of the given statement. Okay. Now you can write one more statement here. Express the contrapositive. Express the contrapositive, converse and inverse forms of the following if p less than b and 1 plus 1 is equal to 2, then sin pi by 3 is equal to 1 by 2 statement. So we have to write down first of all p. P is, it means what? 3 less than b. Q is a statement 1 plus 1 is equal to 2. And R is a statement sin pi by 3 is equal to 1 by 2. The symbolic form the statement is, first we have to write the statement in a symbolic form. So what is it? P and Q implies R. Right? Now we will write down the contrapositive of this. Contrapositive. So you can write contrapositive. Negation of R implies negation of P and Q. Right? So negation of P and Q, it means what? Negation of R implies negation of P or negation of Q. This is your contrapositive. Negation of R implies negation of P or negation of Q. So we can write the statement here. The statement you can write sin pi by 3 is not equal to 1 by 2. Okay, I'm writing here sin pi by 3 is not equal to 1 by 2. Then sin pi by 3 is not equal to 1 by 2. Then 3 is greater than or equal to b, or 1 plus 1 is not equal to 2. Clear? How to write here? 3 is greater. So we will take it in the next slide. Just a minute. Right? This statement we can write in the next slide. If, so contrapositive here, negation of R implies negation of P or negation of Q. It means if sin pi by 3 is not equal to 1 by 2, then 3 is greater than or equal to b, or 1 plus 1 is not equal to 2. This is your contrapositive. Right? Second, we will write down here converse. So converse, it means P implies Q, then Q implies P. So here you will get the converse of this is R implies P and Q. Okay. So R implies P and Q. What is here? R? Sin pi by 3 is equal to 1 by 2. If sin pi by 3 is equal to 1 by 2, then C is less than B, and 1 plus 1 is equal to 2. Yeah. Now, third one is inverse. So we can write inverse of this statement. So inverse of this is, so P implies Q. So inverse of this is Q imply, negation of P implies negation of Q. So here negation of your statement is in symbolic form. Negation of P and Q implies negation of R. This is your inverse. So negation of P and Q, it means negation of P or negation of Q. Negation of P or negation of Q implies negation of R. So you can write the statement if C is greater than or equal to B, or 1 plus 1 is not equal to 2, then sin pi by 3 is not equal to 1 by 2. This is your inverse. So converse, inverse and contrapositive, how to write? I think all of you are getting it. How to write the converse, inverse and contrapositive of the given symbolic form. Or if it is given in the only sentence statement form, first of all it is converted into symbolic form and then you will get it in converted into the again by using that symbolic form. Right? Now, show that P implies Q, double implies negation of P or Q is a tautology. Okay, we have to show that tautology. Tautology, it means what first? If all the statements, truth value of the given statement is uh, truth value of the given statement is true, then your statement is tautology. If all the statement truth values of the given statements are false, all the truth values are false, then it is contradiction. And if either true or false, then you will get it is a contingency. Okay, so show that it is a tautology. So for that we have to prepare the truth table first. So P, what we required, P, Q, P implies Q, negation of P, then negation of P or Q, and last P implies Q, double implies negation of P or Q. P, P, F, F, right? So here T, F, T, F, P implies Q. You can write this truth table. If second statement is false, then only false, otherwise it is true. Negation of P, false, false, true, true. Negation of P or Q. So first the negation of P or Q. True, false, true. False, false, false. True, true, true. True, false, true. Right? Now P implies Q. Double implies negation of P or Q. So both are true, then it is true. Both are false, then also it is true. Both are true, then it is true. Both are true, then it is true. So the truth values of the given statement is true. All the truth values are true. Therefore, it is a tautology. Therefore, the given statement is tautology. Hence, P implies Q, double implies negation of P or Q is a tautology. Okay? Now, prove that P double implies Q here. You can see here P implies Q implies R. Double implies, here double implies, only implies. P implies Q implies P implies R. Now very interesting. Now check whether it is tautology or contingency or contradiction. We will see here. P, now there are three statements. P, Q, R. So three statements. So here you will get truth values are 8. True, 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 false, 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 false. Okay. Now second, here Q8 means both true, both false, both true, both false. One true, one false, one true, one false, one true, one false, one true, one false. So PQR. Now Q implies R. We require first Q implies R. Then P implies Q implies R. Then we require P implies Q. Then P implies R. Okay. So P implies Q, implies P implies R. And finally, now we'll say that this is our statement B, and we say that P implies Q implies R is a statement A, and finally we prove that A implies B, right? So we'll say here Q implies R, T T T T F F, F T T F F F, T. First true, second false, then false. Here is T, false, T, T, right? So you will get Q implies are this. Here Q it means. Now P implies Q implies R. P implies Q implies R. T T T, T F F, T T T, T T T, F T T, F F T, F T T, F T T, right? P implies Q, T T T, T T T, T F F, T F F, F T T, F T T, F F T, F F T, right? P implies R, P implies R, T T T, T F F, F T T T, T F F, F T T, F F F, sorry, F F T, F T T, F F T. P implies Q implies P implies R. So these two. T T T, T F F, F T T, F F T, T T T, T T T. Now A implies B. T T T, F F T, T T T, T T T, T T T. Now see if we say all are true. So this is your tautology. All the truth values are true. So this statement is a tautology. So here we have to give and check whether the given statement is contingency, contradiction or tautology. So this statement is a tautology because all the truth values of the given statements are true. Okay? Now we'll see once again the statement. Now check whether the given statement is tautology, contingency or contradiction. So P and Q and negation of P or Q. Okay, so P, Q only numbers here. P, Q require P and Q. Then P or Q, negation of P or Q. Then here is A, directly you can write P and Q and negation of P or Q. So T, T, F, F, T, F, E, F, P and Q both are true, then true, otherwise it is false. Right? P or Q both are true, then true. Any one of them is true, then true, otherwise it is false. Negation of P or Q. F, 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 P. P and Q and negation of P and Q. And false, 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 false. The given statement is contradiction. Given statement is contradiction. Okay? Because all the truth values are false. Now, now seventh one we will see. In this example, we will find out whether it is contingency or not. P or Q and negation of P. Check whether it is contradiction or contingency. Okay, and here is negation of P and Q. Q, T, T, F, F, T, F, E, F. P or Q. Both are true, then true. Any one of them is true, true, false. Both are false, and only false. Negation of P, F, F, T, P. P or Q and negation of P. And P or Q and negation of P and negation of P and Q. First we will calculate and negation of P. Negation of P and Q. Negation of P and Q. And negation of P and Q. So there is also okay. Then negation of P and Q. P, E, F. So this is, so there is A and there is B. So A and B. Okay. False, false. Again it is contrary. Okay. Now we'll see the logical equivalence. Then we'll see logical equivalence. Now, if the two statements are equivalent or not, we will see. Here negation of P or Q is equivalent to negation of P and negation of Q. Okay, is equivalent to, so by we will prove this by using truth table. P, Q, negation of P, negation of Q, P or Q, negation of P or Q, then negation of P and negation of Q. Negation of P, F, F, T, T, negation of Q, F, T, F, T, P or Q, negation of this F, 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 T, P and Q, F, T, F, P or Q, negation of P and negation of Q, false. The negation of P and Q, false. Now, if you observe, this is 1, 2, from one end to both the truth tables are same. So therefore, negation of P or Q is equivalent to negation of P and negation of Q. We'll use this logical connectives to solve the DNF and CNF. Okay, so you must know the logical connectivities for this. So P implies Q is equivalent to negation of P or Q. Okay, we'll check P, Q, P implies Q. Right here we will see the P implies Q. Required negation of P, negation of P or Q. There is T, T, F, F, T, F, T, F. P implies Q, T is F, here is T, here is T. Negation of P, F, F, T, T. Negation of P or Q, F, T, F, or, sorry. One of them is true, then it is true. Negation of P or Q, P or Q, F, F, F. Here T, 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 F, T, T. So if you observe, this is 1, 2, both the truth tables are same. Therefore, P or Q is equivalent to negation of P or Q. Right? Now, one more, second logical connectivities. Third one, logical equivalence, we will prove negation of P and Q is equivalent to negation of P or negation of Q. Negation of P or negation of Q. Right? So these two are equivalent. So we'll check whether it is equivalent or not by using truth table. P and Q, negation of P and Q, negation of P, negation of Q, and negation of or negation of Q. So here T, T, F, F, T, F, T, F, P and Q both are true, then true, T, F, 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 F. negation of P and Q, F, T, T, T. Negation of P, F, F, T, T. Negation of Q, F, T, F, T. Negation of P or negation of Q or. There is F, there T, T, T. Now if you observe, this is 1 and this is 2. From 1 and 2, both the truth tables are same. Therefore, it is equivalent. P and Q is equivalent to negation of P or negation of Q. Okay. So we will see now. Now, absorption laws we can see here for the logical connectivities of absorption laws. Okay. First one, P or P and Q is equal to P, equivalent to P. We can prove it by using truth table, right? See, P, Q, P and Q. This P or P and Q. T, T, F, F, T, F, F. P and Q. There is T, 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 F. There is F. There is F. P or P and Q. T, T, F, F. Right? T, F, F. Now, if you observe the from first and second, TTFF, TTFF. Therefore, P or P and Q is equivalent to P. This is known as absorption law. Okay. Exactly similar way we prove the second absorption law. P and P or Q is equivalent to P. Again, we will prove P, Q. There is P or Q. P and P or Q. T, T, F, F. T, F, T, F. P or Q. T, 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 F, P and P or Q. T, 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 F, F. If you observe from 1 and 2, both the tables are equivalent. Truth tables are equivalent. Therefore, P and P or Q is equivalent to P. Okay. These are the absorptions law. And we know that here we already proved P implies Q is equivalent to negation of P or Q. We will use this to find out the CNF and DNF. It means conjunctive normal form and disjunctive normal form. That we will see in the next lecture how to find out the normal forms by using truth table also and by using without truth table also. Okay, that part we will see in the next lecture. Thank you so much for listening. If you are liking my videos, please do like, share and subscribe. Thank you so much.